Example 2, evaluate each expression. So now we're going to take the idea of radicals and rationals, we're going to stick them all together, and we're going to see what we come up with. So again, assuming we are not working with a calculator here, because eventually I promise these will get harder and your calculator won't do it, 16 to the 3/4 power. If I'm just looking at 16 to the 3/4 power, I really don't know what to do with that. So the first thing I'm going to do is I'm going to rewrite it in radical form. 16 is my base, so 16 is going to go inside. 4 is my denominator, so it's going to be my root to the power of 3. And again, you can put this in parentheses and raise the whole thing to the 3rd power, or I can just take my 16 and raise it to the 3rd power. Now, at this point, you can choose. You can choose to either figure out the index first, or you can choose to figure out the power first. It's completely up to you. Now, if I'm looking at 16 to the 3rd power and I'm not using a calculator, I have no idea what 16 times 16 times 16 is. So I am not going to do 16 to the 3rd power. But what I am going to do is I'm going to do the 4th root of 16, because that's telling me I need 4 of the exact same thing that multiplies together to get to 16. And if you remember our last video, that was 2. 2 times 2 times 2 times 2, there's 4 of them, when multiplied together is 16. So this answer right there, the 4th root of 16, is 2. Then I have to go back and consider, but I didn't use the 3rd power yet. So really, this is 2, but it's 2 to the 3rd power, which is 2 times 2 times 2, which is 8, and you're done. The final answer to 16 to the 3/4 is 8. Letter C, 27 to the 4/3 power. Again, I'm going to rewrite, so I'm going to have my radical, 27 is my base, 3 is my root to the power of 4. Now, once again, you can choose. You can either do 27 to the 4th power, or you can do the cube root of 27. 27 to the 4th power, 27 times 27 times 27 times 27, that's not happening. I mean, if I had a calculator, great, but I don't. So I'm going to do the cube root of 27. I need 3 numbers that when I multiply them together, the exact same number, I get 27. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So the cube root of 27 is 3. Then I have to go back and say, but I didn't use my 4th power yet. So I'm going to take 3 to the 4th power, which is 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Final answer, 81. Letter B, the cube root of negative 125. This one, probably not too bad if we're good with our numbers, but there's nothing funny here. It's just a radical. So we're looking for 3 identical numbers that when you multiply them together, you get negative 125. So negative 5 times negative 5 times negative 5. Negative 5 times negative 5 is positive 25, times negative 5 is negative 125. That'll work out. So the cube root of negative 125 is negative 5. Now, remember in that last video where we tried to do like the 4th root of negative 16 and we said, no, 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 that won't happen? Why could we not do the 4th root of negative 16, but we can do the cube root of negative 125? Think about that for a minute. But really it comes down to an even root versus an odd root. You cannot take an even root of a negative number. And I apologize, actually you can, but it's not real. Okay, and we'll deal with this when we get to chapter 4. But for the sake of right now, when we're dealing with real numbers, this is not a real number. I can't find a real number that when I multiply the same thing 4 times, I get to a negative. And the reason is if I have a negative 2 times a negative 2 times a negative 2 times a negative 2, every group of 2 is going to make a positive. because a negative times a negative is a positive. You need that third guy to add the negative back on to get you to a negative answer. So odd roots, yes, you can do negatives. Even root, you can't right now, not until we get into our imaginary numbers. Letter D, 9 to the 5 halves power. Sorry about that tangent that I got off on the last one. So same deal. I'm going to rewrite it as a radical. 9 is my base. 2 is my root. 5 is my exponent. Now, technically speaking, if this is a second root or a square root, you don't need this. In fact, you won't even see it. It would just be written like that. It would be written as the square root of 9 to the 5th because the 2 is implied. So if you ever see a root that has nothing here, there's a 2. You just can't see it. Now again, 9 to the 5th power, I'm not doing that in my head, but I do know the square root of 9. 3 times 3. So the square root of 9 is 3. Then I have to do my 5th power. So 3 times 3 times 3 times 3 times 3 is 9 times 9 times 3, which is 81 times 3, which I think is 243, but I'm going to check. 81 times 3 is 243. So final answer, 243.